Welcome to Spring LIB.
Once again, welcome to a new problem. Still, we're dealing with slits, not exactly diffraction, but more conceptual slits. Assume we have two slits running side by side, and the width or the gap between the slits happens to be D. So this gap right here is given as D, and then the slits themselves have a distance of A, so that's the information we're given. And assume also that these two slits, the first one and the second one, they combine with each other up until, well, first of all, we're assuming that D equals to A, so the gap between the slits is equivalent to the width. So this is the gap between the slits, and this is the width of the slit, and they're equal to each other. And the two slits combine such that they become a single slit with width A. So, imagine these two slits, the first one and the second one, bump up together and end up becoming 2A in width. So our goal in this particular problem is to the equation, if the intensity, we have an intensity is equivalent to Im cosine squared beta sine alpha over alpha squared. We assume we want to show that this equation is going to reduce. We want to show that equation is going to reduce and reflect, reduce and reflect a specific diffraction outcome. So that's what we want to solve. If we have two slits coming together to form a single slit, there's a specific equation that collapses. So the equation collapses and forms a new equation that reflects a specific disposition or specific outcome or specific pattern. So we want to see that. So given that equation, we know that beta equals to pi d over lambda. Remember, d is the gap between the two slits and lambda is the wavelength. Lambda is the wavelength. So sine theta, and then theta is the angle of diffraction. If diffraction happens, this angle is going to be theta. The wavelength that's coming in, that's lambda, not gamma. And beta is a constant. So beta is a constant that we're dealing with. Alpha is also another constant, and it's given by pi d over lambda sine theta. So that's what's given. We know that d equals to A and alpha equals to beta. If that's the information given, we can collapse the equation to intensity theta equals to Im cosine squared beta sine squared alpha all over alpha. So we want to see where all this is headed. Remember, this is sine squared also. We want to see that. So I theta becomes Im cosine squared beta cosine squared beta times alpha, cosine squared beta times alpha sine squared alpha all over alpha squared, sine squared alpha all over alpha squared. So that's what we have in the equation. Since alpha equals to beta, so we did a replacement right there. So this beta became alpha, and now we have a new relationship. And so this simplifies to Im. Cosine beta, remember this is no longer beta, this is gone, so we've replaced it with just alpha. So we've replaced it with alpha. As you can see, this is we need to get rid of this. So this is alpha right here. This is alpha. This is alpha. We're doing the replacement. So Im sine squared 2 alpha all over alpha squared. Remember, cosine squared alpha, sine squared alpha simplifies to sine squared 2 alpha all over 4. And so this is over 4. We've simplified that. So we continue and see that I theta is the same as Im sine squared 2 alpha all over 2 alpha squared. The reason why this is 2 alpha squared is because if you have 4 alpha squared, this simplifies to 2 alpha squared. So 2 alpha squared is going to give you the same thing, like that. So once again, we had a problem. And in this particular problem, we were given 2 openings, this one and that one, and these 2 openings collapsed to 1 opening. Lambda was our wavelength, theta is the angle of diffraction, and d is the gap between the slits. Each slit was equivalent to A. Each slit was equivalent to A, so we want to see if the 2 slits become a single slit. This equation that represents that relationship will collapse to a reduced equation which has a specific diffraction outcome. So we have an understanding that we have 2 constants given, alpha and beta, and d equals to A. So the slit width A is equal to the gap between the slits. Alpha is beta. We do a replacement of alpha with beta, and then the problem collapses to Im over 4 sine squared 2 alpha over alpha squared, and simplifies to Im, which is intensity, sine squared 2 alpha squared. So hope you enjoy the problem. Feel free to send any questions or comments, and have a wonderful day.